CLI Plotter is a Python program which implements numpy and matplotlib to plot polynomial functions through a simple-to-use command line interface. This program will plot a polynomial function up to second degree and create a .png file of the graph. When it is run through the command line, the program will ask the user for the values of the square, linear, and constant coefficients. If the desired equation does not have a square or linear coefficient, the user should enter 0 when asked for these values. It will then create a plot of the function and display an image of said plot to the user in a new window. The image will also be saved as a .png file in the directory in which the program is saved. The program will then ask the user if they would like to create a new plot, looping through the same process as above. If a new plot is created in the same session, then the saved PNG of the previous plot will be overridden by the new plot. According to an article published by Source, making a design pattern is a general, repeatable solution to a commonly occurring problem in software design. That is to say that design patterns are ways of writing code so as to make it reusable and to minimize total source code size, while also making an attempt to improve readability of the code for software solutions. The usage of design patterns in software development is key if one wishes to achieve the above goals and improve their software from a comprehensive standpoint. Design patterns can be broken down into 3 categories: creational, structural, and behavioral. Creational patterns deal with classes and objects in object-oriented programming. More specifically, creational patterns describe the mythology of how classes and objects are instantiated in a program, whether it be through interface, inherent from a class perspective, or delegation from an object perspective. In this program, we utilize the creational pattern of object pooling. Object pooling is to pull from the same source-making article. It can be described as a way to avoid expensive acquisition and release of resources by recycling objects that are no longer in use. In essence, object pooling aims to prevent large consumption of memory by reusing already instantiated objects and simply updating its reference data. In our case, we do this by using an object pool that stores the entered polynomial information in 3 inner variables. We then reuse this object if the user chooses to make a new plot by simply changing the variable's values, rather than making a new object altogether. The benefits of this are largely in that this reduces memory usage. Structural patterns are the patterns of how classes and objects are structured. This refers to how objects may be structured to have more control of functionality. Examples include restriction to private class data or abstraction of an entire structure of composite objects to provide a similar interface. Private class data is data that is contained within a class with restrictions on how it is mutated and accessed. These restrictions are enforced by the use of accessor and mutator functions to be used by the source code outside of the class, rather than by direct access to the data itself. According to source making, the motivation for using this pattern is the design goal of protecting class state by minimizing the visibility of its attribute data. In this program, we utilize this design pattern by creating a polynomial class to store the coefficient data related to a polynomial. Access to this data is done through the functions rather than direct contact. The final design pattern is behavioral design. Behavioral design is all about the class's objects communication. These patterns are largely concerned with communication between objects. That is to say, how objects pass information back and forth during a program's execution, as well as the general flow and usage of objects. In this program, we utilize the behavioral design pattern of iteration. Iteration can be defined as sequentially accessing the elements of a collection. In our case, we sequentially access the elements of the polynomial object, as well as during the getYValues function. The latter of these 2 uses is not apparent at first glance as is occurring within the numpy Python library utilized within this program.